so excited to see Grandpa.
Me too. He's been talking about us visiting for a while now.
Let's not keep him waiting anymore.
Yeah, how's everyone doing?
We're great. Thanks for helping Johnny with his school project.
Of course. Anything to help out my grandson.
Recently, we've been talking a lot about our family history and how our species came to be.
So where do we come from, Grandpa? I heard that humans come from apes, but where are we from? And why do we look so different from other crabs?
Well, just as humans are closely related to apes, we're closely related to the extinct trilobites. Have you learned about trilobites in school?
Oh yeah. I learned that they showed up after something called the Cambrian explosion.
Wait, what's the Cambrian explosion?
Oh, that was a great diversification event in the history of life on Earth. 17,000 new species evolved over a period of about 30 million years, around 540 million years ago.
Why did this happen?
There are a few theories about how this explosion could have happened, the strongest being an increase in atmospheric oxygen. With more oxygen, species had to evolve more complex respiratory systems in order to survive, resulting in diversification. Another theory is that changes in the climate are to blame. Before the Cambrian, the Earth was heavily glaciated, but a temperature increase has been observed, which would mean that more life is possible. As species got bigger and more complex, trilobites appeared.
That's interesting. But what is a trilobite anyways?
Trilobites are some of the most important prehistoric animals on record, appearing during the Cambrian explosion around 520 million years ago. Having existed on Earth for around 300 million years, with over 20,000 known species, their appearance can vary pretty dramatically, but they all have a relatively similar structure, with a hard exoskeleton which is divided into three parts: a cephalon, thorax, and a pygidium. Most trilobite species had compound eyes with multiple lenses. However, the quality of these eyes varied wildly between species.
Trilobites lived in marine environments, making them a great indicator of paleoenvironment. Since there are so many different species, the presence of trilobite fossils can also indicate whether the ocean was deep or shallow in a given area, as some were believed to have only lived at certain depths of water. Trilobites led many different lifestyles, with some being bottom feeders and scavengers, not dissimilar to modern-day horseshoe crabs, like us. Others hunted and ate small worms and invertebrates, and some were able to filter their food from the water. Trilobites are important for geologists because they can be used for relative dating as well as stratigraphic correlation. Since we know that they existed between the Cambrian and the Permian, the presence of a trilobite in an outcrop indicates that the age of the rock must fall somewhere in that range. But there are certain species of trilobites that we know enough about to identify specifically. For instance, Paradoxides, a type of large trilobite, only occurs during the Middle Cambrian. So the presence of this fossil would suggest that the surrounding rocks are that age.
Trilobite fossils can also be used to reconstruct past environments and geography. Consider the following example. Two fossils of the same species are discovered on two separate land masses, separated by a vast ocean. It is known to geologists that this species of trilobite only occurs within the Lake Cambrian. With this given information, it can be assumed that these two land masses were once connected and submerged beneath an ocean, where these two trilobites would live simultaneously. The Cambrian explosion was a period of mass diversification, and was when most modern animal groups began to appear in the fossil record. Thousands of species came and went, and few would live to see the beginning of the Ordovician. A series of mass extinctions towards the end of the Cambrian spelled the beginning of the end for the trilobites, as the population numbers for the entire class Trilobita would suffer drastic declines that they would ultimately never recover from, going completely extinct as far as records show by the end of the Permian.
Wait, did we come from trilobites or something else?
Actually, horseshoe crabs haven't evolved further since the Cambrian. We are among the only prehistoric species still alive today. Our species were able to survive this long because of our ability to live through anoxic conditions. Anoxic conditions simply means an environment lacking oxygen.
Whoa, our species is so cool. We've been here forever. But hold on, we're called horseshoe crabs, but are we even crabs?
No, we're arthropods, which are more related to scorpions and spiders rather than crabs.
Yuck! I can't believe we're related to spiders. They're so gross.
Johnny, your cousin Ronald is not gross.
Dad, thanks. This has been so helpful.
Will this be enough for your project, Johnny?
Yes, thank you. I finally know who I am and where I come from.